Good afternoon to all of you. Myself Ashish Kumar Tiwari. So today we are going to discuss one important topic like identification of aromatic, anti-aromatic and non-aromatic compound. So let's start. What? Identification of what? Aromatic, anti-aromatic and non-aromatic compound. Non-aromatic compound. Okay. See, first before this aromatic compound, what is aromatic compound? So aromatic compound simply it is a cyclic compound because of which its stability is increases, like one phenomena, that is aromaticity. Because of that only, compared to other structure, what are the aromatic compound that is more stable. But in that, how we will identify that our compound is aromatic or not aromatic, that we will have some characteristics and some rules. If it is following that rules, it means it is aromatic compound. Otherwise it is some other type of compound like anti-aromatic or non-aromatic compound. Okay, so now for aromatic, if we will discuss, so for any compound, the compound first rule is like it should be cyclic. What? It should be cyclic. Okay, second thing, compound should be planar. Compound should be planar. Okay, third is all the compound should have sp2 or sp hybridized carbon. All carbon should be sp2 or sp hybridized. Okay, see, normally we will tell like in general form we will tell if any compound having sp2 hybridized means it is a planar compound. Okay, now third is it should follow the Huckel's rules. What? It should follow the Huckel's rules. Okay, now for aromatic compound, what are the Huckel's rules? That is 4n plus 2 pi electron system. Means whatever your compound, it should be 4n plus 2 pi electron system, where n is equal to 0, 1, 2 and so on. Okay, one more thing, we will use this one later. Always remember, 1 pi bond is equal to 2 electron. 1 pi bond means 2 electron. Okay, so its simple example if we will discuss, then it is like benzene ring. It is a benzene ring. Okay, we will see how these are aromatic compound, but first we will know the conditions of aromatic, anti-aromatic and non-aromatic compound. Okay, so for anti-aromatic, it should follow all the rules which is coming under aromatic compound, but except this Huckel's one. Here compound should be what? Compound should be cyclic. Compound should be cyclic. Then it should be planar. Okay, planar means what? All the carbons should be sp2 or sp hybridized carbon. sp hybridized carbon. Third one, it should follow 4n pi electron system. Okay, 4n pi electron system. in aromatic, how it is following? It is following 4n plus 2 pi electron system. Okay, so if here example we will take, so it's simply this one. Okay, this is the compound like anti-aromatic compound. Now suppose if any compound will be there, so either it will be aromatic, either it will be anti-aromatic, or it will be a non-aromatic compound. So in non-aromatic compound means what? It will follow like, maybe it may be cyclic compound, but it will be not planar. No planarity will be there. No planarity will be there. See, planarity means what? It means either in that compound, at least there will be one compound which will have an sp3 hybridized carbon atom. sp3 hybridized carbon atom. Okay? Or see, this is the one simplest condition, but sometimes its planarity loss due to its structure, that we will discuss, like because of structure how it will become non-aromatic compound, like some examples are there. So at that time we will discuss, but for time being you should know compound will be cyclic, but it should not, maybe if compound is cyclic, so it should not have its like its planarity will go. Okay, so these are the simple characterization of aromatic, anti-aromatic and non-aromatic compound. Now we will discuss some example, then we will come to know what are the difference between this. So please note down this one. Okay, 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 we will keep this one for our understanding. So here we will discuss some example. So let's start from simplest one. Okay, wait, I will write this one little bit this side. So here we can write like, if for anti-aromatic, everything will be same. Anti-aromatic, everything will be same as aromatic, only what? It will have a 4n pi electron system. Okay, where n is equal to same 0 1 2 and so on. Okay, so for our understanding only we keep this one. So now we will discuss our first example, like benzene ring. Okay, so here if we will see benzene ring, first is what I said, see, compound is what? Cyclic. Second, if you will see, all carbon is sp2 hybridized. All carbon is sp2 hybridized. Okay, it means it has a planarity. It is a planar compound. All compound is sp2 hybridized. Okay, now last one, 3 pi bond. I said 1 pi bond means what? 1 pi bond means 2 electron. 3 pi bond means 4n plus 2 is equal to 3 pi bond means total 6 electron. So 4n is equal to 4, n is equal to 1. Okay, so it means this one is following all the rules which we have written in left side. So it means this compound is a aromatic compound. Okay, aromatic compound. Okay, now we will take that for NT. We will take one more example, this one which we took last time. So this one, now just see, this compound is what? Cyclic. Okay, all carbon is sp2 hybridized, compound is planar because all carbon is sp2 hybridized. And last one, now just see here, what 4n plus 2 means, if you will see 4n plus 2 is equal to 2 to 4, 4 pi electron. So if suppose you are thinking this will follow, so you can calculate, is it following this one? 4n is equal to 2, n is equal to 1 by 2, means it should not come like a in a fraction. But if you will follow, it means it is not following 4n plus 2 pi electron system. So we will see 4n is equal to 4, n is equal to 1. So it is following the anti-aromatic condition. So it means this compound is anti-aromatic compound. Anti-aromatic compound. Okay. So this compound is anti-aromatic compound. Okay. Now we will discuss some more example. Then our concept will be more clear. Now tell, either this compound is aromatic or not. So we will see what here, this is having one hydrogen, so this carbon is sp2 hybridized, sp2 hybridized. This is carbocation. Okay, so but here that how we will discuss, like either this compound is sp2 sp or sp3, that we will discuss later. But here this compound is carbocation, so here it is sp2 hybridized, this carbon also sp2 hybridized, this carbon also sp2 hybridized. You will see compound is cyclic. Since all carbon is sp2 hybridized, that's why it is a planar. Okay, and all carbon is sp2 hybridized, and 4n plus 2 is equal to how much electron? 1 pi bond. 1 pi bond means 2 electron. It means n is equal to 0. It means it is following all the criteria of aromatic compound. So this compound is known as, this compound is also as an example of aromatic compound. Okay, aromatic compound. Okay, now let's see some more example. Let's see, we will see some more example, like this one. Now tell, compound is cyclic, all carbon is, this is also sp2 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 sp2. It means all carbon is sp2 hybridized. Okay, it means it is a planar compound. It means 4n plus 2 is equal to how much electron? 1 2 3. 3 means 6 pi electron. 4n is equal to 4, n is equal to 1. Means this compound is also an aromatic compound. Okay, okay, one more example we will see. Suppose you have this compound. Okay, Now there may be some, so this compound, okay. So now I have already said whatever you have we will consider lone pair that time only when it will be in localized condition. So if here you will see here one negative charge means it contains one lone pair, okay, means two electron. So it is in localized condition. That's why whenever we are going to count the either it is hybridization or its aromatic character, we will count this electron, okay, because it is a localized electron, okay. So that's why this compound is cyclic. You can see all here as p1 p2 means here sp2. If we will consider this electron, so compound this carbon is sp2 hybridized, this is sp2 hybridized, all carbon is sp2 hybridized, okay, okay. And if all compound is sp2 means it is a planar compound, it is a planar compound. And last, if planar means 4n plus 2 is equal to how much? 1 2 3. 3 means 6 pi electron, 6 means 4n is equal to 4, n is equal to how much? 1, okay. So this compound is also aromatic compound, this compound is also aromatic compound, okay. Now see, these are the some example of aromatic and anti-aromatic compound. We can see some more example like okay, we will see this example, okay. Now for this example, just tell compound is what? Compound is cyclic, okay. Next thing, all carbon is sp2 hybridized. sp2 means it is a planar compound, and planar compound means now we have to discuss either it is 4n pi electron or 4n plus 2 pi electron, okay. So here you see 1 2 2 means total 4 electron, so it will follow 4n is equal to 4, n is equal to 1, okay. That's why if you want to see like why it is 4n plus 2 not 4n plus 2 means it will come as 4 and will come 1 by 2, it means it cannot be a fraction, okay. That's why this compound is what? This compound is anti-aromatic compound, this compound is anti-aromatic compound, okay. Now these are the some example and how to solve the like examples in your exam, but we don't have that much time, okay. So we should have some trick, okay. So note down the trick which is very important. We should not do all these things for anti-aromatic or aromatic compound. So here I will tell you one trick, okay. This trick means if any cyclic compound, you just check, like you can do like this also, but you can do if it having suppose if it having odd number of pi bond, it means it is aromatic compound. What it means? It is aromatic compound, okay. Suppose if it having what? even number of pi bond, it means it is anti-aromatic, okay. So you should remember this trick. If any compound having odd number of pi bond, it means it is aromatic. If it having even number of pi bond, it means it is anti-aromatic, okay. Now just see, we can cross check our answer. Just tell 1 2 3. Here how many pi bond? 3. 3 means Odd means what? It will be aromatic. Okay. Now see this one. How many bond? Two. How many number of pi bond? Two. Two means what? Even. Even means what? Anti-aromatic. Always remember this trick you have to apply only on aromatic, like cyclic compound only. Okay. Anti-aromatic. Okay. Now here just tell number of pi bond. How much? Odd. One. One means odd. Odd means what? It is aromatic. So you can cross check all the answers. Here tell 1, 2, 3. 3 pi bond. 3 pi bond means what? Odd. Now you can check. Odd means what? Aromatic. It is also aromatic compound. Now here check 1, 2. 2 means what? Even. 2 means what? Even. Even means anti-aromatic. Okay. Here also you can check 1 and 2. 1 and 2. So 2, because we will consider this one. That's why I am considering this one. Because this is localized electron. That's why I am considering this as a 1 pi bond. Okay. So 1, 1, 2. 2 means what? Even. Even means what? Anti-aromatic. Okay. Okay. So this one is like anti-aromatic. So okay, okay. So these are like anti-aromatic compound and aromatic compound. Okay. Now one more thing, we have to discuss non-aromatic compound. Okay, first you just note down this one, then we can discuss the non-aromatic compound. Okay, only you have to remember, if number of pi bond is odd, it means your compound will be aromatic. If number of pi bond is even, it means it is a anti-aromatic compound. Okay. In future we will study like some quasi aromatic, so like that there some rule is different. Okay, so there we will follow some different rule, but for time being, for any cyclic compound like this, you can simply use this trick. Okay. Okay, we will rough this one. Okay. Okay, now we will discuss non-aromatic compound. Non-aromatic compound. Okay, see now for aromatic and anti-aromatic we have rules. So for non-aromatic, I said compound will be cyclic and it having sp3 hybridized carbon. Because of that, its planarity will go. Okay, and it is non-planar. It is non-planar. See, any non-aromatic compound can be non-planar because of either it having sp3 hybridized carbon, or sometimes it will follow like a distorted planarity will be there because of distorted planarity. Okay, distorted planarity. I will tell you one example. So here, suppose we have taken this one. See, here it is cyclic compound. All here this carbon is sp2, 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 but this carbon is sp3 hybridized. That's why this compound is neither aromatic nor anti-aromatic. This compound is non-aromatic. Okay, this compound is non-aromatic. Okay, now we will take one example which is very important: cyclooctatetraene. See, if you will see, so if you will see this compound and if you will follow all these rules, so definitely you will get it is like a anti-aromatic compound. Okay, you will get like this type of a anti-aromatic compound, but it is wrong. Why? Because it will exist in tabulated. Wait, I will tell you. Okay, okay, this is the tub shape of, this is a tub shape of a compound. Okay, so because of this tub shape, its planarity will go. Okay, this having a, that is known as a distorted planarity. That's why this compound is what? This compound is non-aromatic. Okay, so for today, what we have discussed? We have discussed what is aromatic compound, what is anti-aromatic compound, and what is non-aromatic compound. Okay, so in next class we will see some more example, and we will discuss some more different type of this characteristics of aromatic, like quasi aromatic, aromatic, like this type of compound we will discuss more. So for today, this much is enough. Thank you so much.